that strong acids completely dissociate. And then we plugged that concentration into our equation for Kw, and we solved for the concentration of OH minus, the hydroxide ions. Let's do another practice problem. I'm going to rewrite Kw because I bet we're going to need it because it says practice problems with Kw. Remember, this is H3O plus times concentration of OH minus. And remember, Kw equals 1 times 10 to the minus 14. Okay, now let's read this problem. What are the concentrations of hydrogen ions and hydroxide ions in a 0.1 molar solution of NaOH? Okay, hydrogen ions, this is the H plus part. Hydroxide ions, this is the OH minus part. Again, remember step 1 right up here? We wrote step 1. When you read the problem, the first thing you need to determine is what kind of acid or base is this? NaOH. Anybody remember when you have OH present? This is the strongest base we know. So this is a strong base. So if we write out the dissociation reaction, NaOH plus H2O, I'm going to draw a single arrow because we will have no reversible reaction here. This is going to be the base. It is going to grab, remember sodium is our spectator. We don't care about sodium. So honestly, we're going to cross him out because it's like he's not even present in the reaction. So we have OH minus, it's the base. It is going to grab a hydrogen off of water. When it does so, what's left over from water? Well, OH minus and H2O, okay? And if I start out with 0.1 molar of NaOH, and it's a strong base, because it will completely react, every single molecule of NaOH will react with enough water available. We're going to be left with 0 of it. Okay, we won't have any NaOH left. So what that means is we will get 0.1 molar of OH minus, and we'll actually have a lot of water. Okay, we won't know the concentration of water because it's both a reactant product and the solvent here. But the point I'm trying to make is every time one molecule of NaOH reacts with water, we create one molecule of OH minus. Okay? So therefore, if 0.1 molar reacts with water, we're going to create 0.1 molar OH minus. That's how I got our concentration of OH minus. So we actually just answered this part. What's the concentration of hydroxide ions? 0.1 molar. The other part of the question is what is the concentration of hydrogen ions? This is where we're going to use Kw. We know Kw is 1 times 10 to the minus 14, and that equals the concentration of H plus times the concentration of OH minus. Well, we already know the concentration of OH minus. It's 0.1 molar, so we're going to plug that in. So 1 times 10 to the minus 14 equals the concentration of H plus times 0.1 molar. So we'll divide both sides by 0.1 molar. Cancels out over here. And you should get 1 times 10 to the minus 13. That's the concentration of H plus here. All right, that's the end of that problem. Last few things, and we'll be done with this series of videos. Again, here's our equation for Kw. We're about to get into pH in the next several videos, but before we do, because we now know Kw and we know what Kw equals, we're going to start talking about how we judge solutions as acidic, basic, or neutral. Okay, we're about to talk about how we judge solutions. How do we determine if a solution is acidic, basic, or neutral? And that is with this statement right here. A solution is considered acidic, basic, or neutral based on the balance of the H plus and OH minus concentrations. And remember, in pure water, we know the concentration of these. 1 times 10 to the minus 7. And there should be an M right here, molar. Okay? So here's how, let's look at the statements below this. An acidic solution. For a solution to be considered acidic, the H plus concentration will be greater, this is the greater than sign, greater than 1 times 10 to the minus 7. And the hydroxide ion concentration will be less than 1 times 10 to the minus 7. That means you have more H plus than you do OH minus. Okay? Remember, OH minus is basic. It's a strong base. H plus is acidic. The more H plus you have in a solution, the more acidic that solution is. Okay, for a neutral solution, the concentrations of H plus and OH minus are equal. Okay, they're both 1 times 10 to the minus 7. And for a solution to be considered basic, we're going to have less H plus. Its concentration will be less than 1 times 10 to the minus 7. And the concentration of OH minus will be greater than 1 times 10 to the minus 7. So in a basic solution, the concentration of H plus is less than the concentration of OH minus. That's a lot to remember, so you really just can remember like half of it, okay? Because if we know the concentration of one, we can always find the concentration of the other using our equation for Kw. So there's no point in memorizing all these numbers. Usually we judge acidity or basicity of a solution from the H plus concentration. So that's why we're just going to say, hey, if you know this information here, if you know what your concentration of H plus is, you can always find the concentration of OH minus. So there's no sense in knowing the concentration of both ions. If the concentration of H plus is greater than 1 times 10 to the minus 7, it's acidic solution. If the concentration of H plus is equal to 1 times 10 to the minus 7, it's neutral. And if the concentration of H plus is less than 1 times 10 to the minus 7, that's a basic solution. All right. Last problem in this video series says this. Milk has an H plus concentration of 4.5 times 10 to the minus 7. Is milk acidic, basic, or neutral? What's the concentration of OH minus? Okay, so let's look right up here. 4.5 times 10 to the minus 7 molar. If we look at these numbers, this is greater than 1 times 10 to the minus 7 molar. Okay, and remember, if the concentration of H plus is greater than 1 times 10 to the minus 7, that is an acidic solution. So milk, bet not many of you would really have guessed this, but milk is slightly, not a lot, but slightly acidic. Okay, because 4.7 times 10 to the minus 7, 4.5 times 10 to the minus 7 is greater than 1 times 10 to the minus 7. So milk is slightly acidic. What's the concentration of OH minus? Well, we can use Kw to solve for this. So we'll just plug our numbers in. Kw is 1.0 times 10 to the minus 14. And we're going to plug in our concentration of H plus. We know, so this is the concentration of H plus, and that is times the concentration of OH minus. So to solve for the concentration of OH minus, we'll divide both sides of the equation. And I don't have a very good calculator. I'm going to have to get a better calculator as we go into this chapter. So, you will actually have to do this on your own and determine the answer. But what you do, I don't have a calculator that I can put this into right now. Sorry about that. But you'll do 1 times 10 to the minus 14 in your calculator. And then I would put this in its own parentheses in the denominator because you have exponents in both numbers. So be careful with that when you put it all into your calculator. But whatever this equals, that's the concentration of OH minus. All right? Should be less than 1 times 10 to the minus 7. And that's the end of this question. So that's the end of these videos, and